Dear students, in previous lecture we discussed zero power factor characteristic of an alternator and Potier triangle. Now we are going to discuss the various steps used for obtaining voltage regulation by Potier triangle method or zero power factor characteristic method, ZPFC method. This method gives more accurate result of voltage regulation. Here we deal XAR with MMF, whereas this reactance XL with EMF. How? We will discuss later. For obtaining voltage regulation using Potier triangle method, we need to perform two tests: open circuit test and ZPFC, zero power factor test. So you may write the various steps in your notebook. First, write down step number 1, perform open circuit test of an alternator, already discussed in previous lectures, and draw the corresponding OCC as shown. Step number 2, perform zero power factor test and draw ZPFC on same axis. So let us mark this point as A. In previous lecture we already discussed ZPFC, and we know that this OA, the field current, OA is the field current required to overcome the armature reaction drop as well as leakage reactance drop. Fine. So next step, step number 3, extend the linear part of OCC to get AGL like this. Next, corresponding to rated terminal voltage, let us mark somewhere. Let us say this is V rated terminal voltage. You may write rated. Corresponding to rated terminal voltage, draw a horizontal line so we have drawn a horizontal line. Let this horizontal line meets the ZPFC at a point. Let us mark this is A, then mark it B. Any point, right? B meets at B. Now next step, take this length OA and mark a point. Let us mark this point as C, AB, C. Mark it C, such that the length CB or BC is equal to OA. Fine. Once this point is obtained, draw a line parallel to AGL, air gap line, from here. Draw a parallel line parallel to AGL. This is AGL, and from C draw a line. Let this meets OCC at point D. So we have drawn a line from point C parallel to AGL, and let the point of intersection is D. Now connect the point D with point B, a straight line. Fine. Next, draw a perpendicular from D, and let us mark this point also, D then E. Fine. This is perpendicular on this right angle. This triangle BDE is our Potier triangle, in which this side BE represents the field current required to overcome the armature reaction drop, and this CE is the field current. This CE gives the field current required to overcome the leakage reactance drop, IAXL. Fine. Corresponding to this drop, armature reaction drop, the field current required to overcome this drop is CBE, whereas corresponding to this drop, the field current required to overcome this is this. Fine. And this side of Potier triangle, this is Potier triangle BDE. So this side DE represents IAXL drop. Here we are taking EMF and here we are taking MMF or field, right? So this C represents the field current required to overcome the leakage reactance drop IAXL, whereas this side gives the value of IAXL. So once this side is known, after performing these two tests, we may form this triangle on graph paper, and then we can get the value of this DE. This gives IAXL. Once this IAXL will be divided with rated armature current, we will get the value of XL. Now XL is known. This XL is known with the measurement of this DE by dividing DE with rated armature current. Fine. Once XL is known, we will try to evaluate the value of air gap EMF, resultant EMF ER. So this is phasor diagram for lagging power factor, this is phasor diagram for leading power factor. This is our terminal voltage V, and this IA current is lagging with power factor angle theta. So we know that ER is nothing but, we may write here, ER is equal to V plus IARA plus J IAXL. We are talking about ER, not EF. If you want to get the phasor EF, then we need to add this phasor also in this ER, right? Check your notebook, we have already discussed these things. So how to get the magnitude of this ER? For that, just extend this line, IA line, as well as this line. Obviously, this will be 90 degree. Fine. This is JIA line and this is IA line. So this will be 90 degree. So we are getting one right angled triangle. Fine. You may mark some points. Let us say this is O, this is A, this is O, or better some other. We have marked A somewhere, right? P, and this is as Q. So in triangle OPQ, right angle triangle, if you want to get this ER, that is hypotenuse, then we need to get the square root of a square of this side plus a square of this side, or in other words we may write ER magnitude. Okay, take a square, hypotenuse a square, this side is square. So this side will be this length, we want to take this length. So we know this is V, draw a perpendicular. So this will be a parallelogram, and this will be the horizontal projection of V cos theta plus IARA. Just write down, write with me, V cos theta plus IARA square, this is OQ square, right? Plus we need to take the square of this. So this is IAXL and this is V sin theta plus V sin theta plus Ia XL square. For leading power factor, again extend this line. Let us extend this Ia line and this also JIA line, the same. So we will get one right angle triangle. Let us mark this as O. This is P dash and Q dash. So in right angle triangle O, P dash, Q dash, if you want to write this hypotenuse, that is this, then we will write this square plus this square. So this square, again take projection of this V somewhere, not necessarily meeting Ia, somewhere. So this length will be V cosine theta, power factor angle theta, by which Ia is leading V phasor, right. So same V cos theta, and this length will be IARA. So V cos theta plus IARA will give this OQ dash square, plus we need to write this square. So this may be written as this minus, not P dash, we want to write ER, right. So our P dash will be here, somewhere here. This is ER, right. So okay, in this right angle triangle O P dash Q dash, this is common, O Q dash square we have written, and then next will be P dash Q dash square, and P dash Q dash is nothing but this length minus this length, and this length is nothing but V sin theta, the same V sin theta. Then we need to subtract this in order to get this. So this will be IAXL. So just we need to put minus sign for leading power factor. Formula will be same. We have already discussed these things, right, in our previous lectures. No need to worry. So by anyhow we will get ER. Once ER is evaluated from OCC, let us take some point corresponding to ER. Let us mark this point as this ER. Let us say somewhere this is ER. The value of ER obtained using this formula, and this formula required XL which has already been evaluated with the help of measurement of this side of Potier triangle. Fine. So corresponding to this ER, we are getting the field current IR from OCC, as we have already assumed that, okay, we are taking the actual values. We have not ignored RA here, we are taking, because for practical evaluation RA must be considered. So corresponding to this ER, we are getting IR like this, and we have already discussed in our previous lecture that this IR leads ER by 90 degree. Similarly, this IF leads EF by 90 degree, and this IAR leads EAR. EAR is minus J times IAXL. If you want to write here, then you may write like this phasor as EAR. So this is EAR, this, and this is IAR, hence IAR is leading EAR by 90 degree, IR is leading ER by 90 degree, and IF, the main field excitation corresponding to no load EMF, leads this by 90 degree. Fine. So this EF may be written as ER minus EAR. You may write here this EF phasor may be written as ER phasor minus EAR phasor, and corresponding excitation currents lead the corresponding EMFs by 90 degree. Hence we may write IF, and here we have written IF0 may be written as IR, this IR minus IAR. Fine. Now we will try to get the value of IF so that we can get the value of EF. So IF can be obtained by adding the two phasors IR and minus IAR, adding, right? So plus or minus of this, right? Vectorially. So we are going to add these two phasors vectorially. So IAR is in phase with IA. So minus IAR will be opposite to that, this, and this is IR. So vector sum of these two phasors, phasor sum, will give you IF0, this IF0. The main field current corresponding to no load EMF. Fine. So with the help of these two phasors, we will get these phasors. So this phasor will be IF0 may be evaluated as under root magnitude IR square magnitude plus minus square we are taking, okay. You may take minus IAR square. No, this is already minus AR. So directly write magnitude, right? Plus twice of these two magnitude, right? IR into IAR into cosine of angle between these two. So angle between these two will be, see this angle, we want to write this angle. See, angle between IR and minus IAR is 180 degree. So after subtracting these two, theta and delta R, where delta R is angle between ER and V, air gap EMF and terminal voltage. So we will get 180 minus these two will give you this, and we know that this is 90 degree. So again subtract 90 degree, then it will be 90 degree minus this. Fine. But we need to evaluate this delta R again. From this phasor diagram, we may get this delta R. Let us again extend this line in order to evaluate delta R. So this is right angle triangle. Fine. In this right angle triangle, if we want to write tan delta R, fine, I am writing here. If we want to write tan delta R, so tan delta R may be written as this upon this, and this is theta, it means this is also theta. Fine. If this is theta and this is 90 degree, then this is 90 degree minus theta, this is 90 degree minus theta, and this is 90 degree, hence this will be theta again. Fine. So extend this line further and this also parallel to V. So again this will meet at 90 degree. This length is hypotenuse of this triangle. Let us say R and S. So in right angle triangle PRS, if we want to write PR, then this will be IAXL cosine of theta, and this length will be, again draw one perpendicular here. So this is theta, this is IARA cosine theta, this will be IARA sin theta. So I am going to write T. Right angle triangle OPT. This is hypotenuse, this is perpendicular, this is base. So this perpendicular PT may be written as PR minus TR, and PR is IAXL cos theta. I am writing here IAXL cos theta PR minus IARA sin theta minus IARA sin theta. This is PT. So tan delta R will be PT upon OT. So write down OT. OT will be V plus this plus this. Let us say this U. So OT will be OV plus this plus this. This is IARA cos theta. I am writing here V plus IARA cos theta. Check yourself. IARA cos theta plus this will be IAXL sin theta plus IAXL sin theta. Fine. This upon this for lagging power factor. For leading power factor, this is delta R, angle between ER and V. And for getting delta R, again draw one perpendicular on this line. Let us mark one line. Draw one perpendicular here, so that we will get OP dash and R dash. One right angle triangle here. OP dash R dash is one right angle triangle in which OP dash is the hypotenuse giving the magnitude ER. But we need to get the value of delta R, so we need to get tan delta R as ratio of P dash R dash upon O R dash. So for writing P dash R dash, if this is theta, this is theta, and this is IA, and this is IRA line, then this will be theta. Fine. Draw one line perpendicular to this. This is 90, this is 90, so this will also be 90. Fine. So these two lines are parallel. If this is theta, this is theta. Fine. This is theta, this is, and this is 90 degree, right? IARA, J IARA. So theta, 90 minus theta, so this will be theta again. Fine. So in order to get this P dash R dash, we need to add these two, this plus this, and this is IAXL cos theta, same IAXL cos theta plus this line, and this line will be, see, draw one line here, right, parallelogram. So this is IARA, so this will be IARA cos theta, then this will be IARA sin theta, and this will be the same as this. So plus sign will be there, IARA sin theta. Here plus sign is coming, just plus sign is coming instead of minus sign in case of leading power factor in numerator. What about denominator? So this tan delta R will be this P dash R dash upon O R dash, and O R dash will be, we need to get O R dash. So first take V, this V, then again take IARA, this one, cos theta, okay, the same IARA cos theta, we have taken this, but we need this only, then we need to subtract this, and this is same as this, and this is IAXL sin theta. This length is, this is IAXL, this is theta, so IAXL cos theta, IAXL sin theta. So we need to subtract this, that is this, and this is IAXL sin theta, so put minus sign here. So upper sign is for lagging power factor case and lower sign is for leading power factor case. For unity power factor, just put theta as 0 degree. So by anyhow, now we can get this delta R also. Once delta r is known, theta is already known, so this angle is known. So this angle for lagging power factor, we may write 90 degree minus delta r minus theta under root. For leading power factor, this IF0, which is resultant of these two phasors, again IR and I minus IAR, IR and minus IAR, this relation. This is ER, so IR is leading ER by 90 degree. This is EF, so IF will be leading like this. Whatever, no need to worry about EF, we need not to evaluate EF. Directly from these two phasors IR and IAR we can get IF. Fine. And this magnitude can be evaluated using this relation. This plus cosine of here, the angle will be different. This will be 90 degree minus delta r plus theta. So only sine will be different for leading power factor. Fine. Or theta may be substituted, negative of that theta. Fine. So we will get IF. How this 90 degree minus delta r? We know that the angle between IR and IAR is 180 degree. So, and this is theta and this is delta r, then this will be theta minus